So now we're going to abandon the calculator altogether and just use our brains. In the construct understanding on page 124, it gives us this question and it asks us to sketch the graph with given the characteristics. So we're going to have to look at the graph and go, well, I suppose I should have done that. But anyway, I want to look at this graph or this equation and try to figure out what sorts of clues I've got as to how I could graph it. And the first thing we want to look at, of course, is the denominator. What are the non-permissible values? And x squared minus 1 is a pattern. It should trigger in your brain, oh, that's a square minus a square. 1's a square. Don't forget that. It's a tricky one. So what you're going to do is go, I can factor that. Difference of perfect squares is easy to factor. I'm just going to write out y equals x minus 1 over x minus 1 times x plus 1. Square root of this is x, square root of this is 1. Make the signs different from each other and you're good to go. So obviously I've got I have two non-permissible values. For this one, x cannot equal 1 because 1 minus 1 would be 0 and then the whole thing would be 0 and then we can't have anything divided by 0. This one, x cannot equal negative 1 for the same reason. So we've got our non-permissible values, but we have to ask ourselves, does anything factor out? If it factors, we have a whole instead of an asymptote. And when I look here, I see there's an x minus 1 and an x minus 1. Therefore, these guys will disappear. I still can't have my x equal to 1 because the original equation would have made it 0. And I'm canceling these out to simplify, but they're still kind of there in the shadows. They're still the original equation, so we have to honor that. What we're going to get is a new equation where y equals 1 over x plus 1, but x cannot equal positive or negative 1. So, now what? What else do we know? Well, we know that we have x over x squared, and when we have x over x squared, then we have an asymptote at y equals 0. So what I can do here is I can actually draw in my asymptotes. So y equals 0 right along this line. So this is going to be my asymptote. Make a dotted line there, and I know that no line is going to be able to touch that. It's going to come close to it, not going to touch it. And then I'm going to look down here and decide that this one factored out, so that's going to be a whole, but this one didn't factor out, and therefore that's going to be an asymptote as well. So I'm going to go over to x cannot equal negative 1. We'll just make a little tick here on our graph for negative 1. And then we draw our line. Move that over for clarity. So we know we have an asymptote at x equals negative 1. And if you remember from previous sections, we got to place that hole somewhere. We have to do that by using the modified equation and plugging in the value that x couldn't be up here. So if I do that, then my y is going to equal 1 over, x couldn't equal 1, so 1 plus 1, which would give me 1 over 2. So my whole is going to be at x is 1 and y is 1 over 2, or 0.5. So I can go back to my graph here and I could just draw myself a little hole using an open circle at 1 and 0.5. So call that 1, call this 1, so about there. So that kind of lets me cheat a little bit because I know that these lines the line that I'm about to draw for the graph can't touch the asymptotes, but they do go through this point. So that means that, roughly speaking, I can sketch this graph going, it's going to have to go this way and that way, which means that it's really likely that this one is going to be a mirror of that on the other side. And you can always test that by picking a point that should be along this line and plugging it into the original equation.